All right, we're going to do a quick lesson on something you've probably already done before, and that is using proportions to find the missing sides of triangles or other shapes, but we're going to mostly work with triangles. And the reason we're doing this now is because you can only do this if the triangles you are working with are similar. This will not work with any other two triangles. The triangles have to be similar to each other. So in this first example, and we've seen this diagram before, we know we have similar triangles because we can match up the angles. We have two pairs of congruent angles. So by angle, AA, these two triangles are similar. And when they're similar, we know that their sides are proportional. So we can set up a proportion by matching up sides. And the way that's going to work is we're going to take the 16. That's going to match up with 24 because those are the longer of the sides that we are given. So we're going to say 16 over 24. And then we'll match up the x and the 21, our other pair of sides. And again, because these triangles are similar and the sides have to be proportional, we know these two fractions have to be equal to each other. So that's what you're going to do. You're going to set up a proportion or two equal fractions. And the way we solve these is by cross multiplying. And when you have your variable, your x on top, this becomes pretty simple. All you have to do is take the 21, the number on the bottom, and multiply it by the numerator, the top number of the other fraction. So what's going to happen here is you're going to have 16 times 21 over 24 is equal to x. And then you just have to multiply and divide that. And so 16 times 21 is 336 over 24. And if you divide that, you will get 14. So x is equal to 14. So that's how that works. I'm going to do one other thing on this particular problem because there's something else you could have done early on if you wanted to. When we had 16 over 24 equals x over 21. If you have a calculator, this is no problem. But if you're working this out by hand, I probably don't want to take the time to multiply 21 by 16 and then divide that number by 24. So what I can do is I can simplify 16 over 24. Simplify that fraction, it becomes 2/3. And now this is much easier to work out. So now I take 21 times 2. That's going to give me 42. And then over 3 equals x. And then I just have to take 42 divided by 3, which is 14. So if you want to simplify the fractions first, sometimes that will save you time and give you an easier problem to work with. Let's do a couple more. Here we have 3 pairs of sides marked, and we have one that's missing, the x. And so the first thing we need to do is figure out what does the x go with? Which side does the x match up with? And if you look at the x, it is in between the angle with 3 arcs and the angle with 1 arc. So we look on the other triangle, we find the 3 arcs, and we find the 1 arc. And the angle that's in the middle there, or the side that's in the middle between those angles is 8. So x goes with 8. And then for our other fraction, we have a choice. We can use either of the other pairs of sides. We can either use the 3 and the 6 or the 5 and the 10. It really doesn't matter. I'm going to go with the smaller numbers just because smaller numbers are easier to work with. So I'm going to do 3 over 6. And now I can cross multiply. I can multiply my 8 by the 3 and then divide it by the 6. So 8 times 3 divided by 6, that's 24 divided by 6. And then x is going to be equal to 4. So that's my final answer. One thing I want to point out here is, like with any problem in geometry, it's always good to make sure your answer makes sense in the problem. So if I look at my 2 triangles, we said side x goes with the 8. The x and the 8 match up. If you look at the 8 and compare it to the other sides on its triangle, it's the middle side. We have a 10, which is bigger, and we have a 6 that's smaller. And then 8 is right in the middle between those two. So we should get a number on the little triangle that's in the same position. So if x is 4, like we found, 4 is in between 5 and 3. It's neither the largest nor the smallest. So it's doing the same thing in its triangle that 8 is doing in the big triangle. So that's one way you can check and make sure you worked it out correctly and have a number that makes sense. One more example. These triangles, again, are similar. The last set of triangles, you notice all 3 pairs of angles were marked, so we knew for sure those were similar. Here we have angle, angle again. We've got 2 pairs of matching angles. And we have 2 missing sides right now. We have X and we have B. So the first thing to identify here when you're missing 2 things is to make this work, we have to have 1 pair of matching sides. 1 pair of sides where we actually know the number for both triangles. And the place we have that is with 10 and 15. Those match up. Those are the long side of each triangle. So we're going to make that fraction 10 over 15. And then I'll start by finding B. B goes with the 8. And so I've got to make a fraction with the B and the 8. And here it's really important to make sure you get the right number on top and the right number on bottom. So B is part of the same triangle that the 15 is. So B has to go wherever 15 is. So since 15 is on the bottom, B goes on the bottom. 8 is part of the triangle with the 10. Since 10 is on top, 8 is on top. So there are different ways you can set these up, but the way we've set it up here, the B is on the bottom. So we have 10 over 15 equals 8 over B. To work this out, we're going to cross multiply. This time we're going to go both ways. When your variable's on the bottom, this is the better way to do it. Cross both ways. So B gets multiplied by the 10. You have 10B. But then the 15 also gets multiplied by the 8. And you have 15 times 8, which is 120. And then to solve for B, we can just divide by 10. And B ends up being equal to 12. And that number seems like it's in the right ballpark for that triangle, but let's keep working and make sure it's consistent. Let's go ahead and find X. So I'm going to use the 10 over 15 again, that fraction we found at the beginning. And I'm going to match the X up with 9. X and 9 go together. And X is going to go on top because X is part of the triangle with the 10. 9 is on the triangle with the 15, so it goes on bottom. And here, unlike the one we just did with B, since X is on top, we only have to multiply by the 9. We only have to cross one way. So we have 9 times 10, that's 90, divided by 15 equals X. And so you divide that, 90 divided by 15 is 6, so X is 6. So we have X is equal to 6, and B is equal to 12. And when you look at this, what you want to make sure, again, is that the sides match up. So 15 and 10 are the largest sides, and they're in the same spot. They're in between the 2 angles that are marked. 9 and 6 are the smallest sides in their triangles, and they're in the same spot. 8 and 12 are the medium sides, and they're in the same spot. So just make sure the triangles are arranged the same way, and if they are, then you've probably worked it out correctly. So the other thing I just want to point out before I wrap this up is, again, just notice when your variable's on top of a fraction, to solve for it, you only have to cross multiply one number, and that's the number that's underneath your variable. So like what we did right here with the X, we just had to multiply the 9 by the 10, and then we could work it out. If your variable's on the bottom, you've got to cross twice because you don't want the variable on the bottom. You got to get it out of there. So like with B, we had to multiply B by the 10 and then also multiply the 15 by the 8. So there is a slight difference depending on how you set the problem up. So hopefully this looks familiar. This is something I'm sure you've done before at some point. But that is using similar triangles and proportions to find missing sides.